Hi everyone, we're going to learn the first learning target for Unit 8, Sequences and Series, Learning Target 1. I can identify the difference between arithmetic and geometric sequences. It's the first part of this learning target. I can determine common differences and ratios. That's the second part. And I can find missing terms in sequences. That's the third part. And today is the 15th, unless you're watching this earlier or later, than what I posted, 2020. I encourage you to write these notes down in your notebook and use them to help you with the worksheet. Ask me any questions, pause the video, slow down the video, speed up the video, whatever you need to do to learn this learning target, do it. So here we go with part 1. Identify the difference between arithmetic and geometric sequences. We're going to start with some vocab. So what is a sequence? A sequence is just an ordered list of numbers. So 1, 2, 3, 4, that's a sequence. 2, 5, 8, 11, that's a sequence. 2, 4, 8, 16, that's a sequence. 40, 20, 10, 5, that's a sequence. The difference between arithmetic and geometric is what type of pattern you see in the sequence. So arithmetic sequences have adding or subtracting patterns, where you add and subtract the exact same number over and over and over and over again. So if I add 1 over and over and over again, I get this first sequence starting with 1. The second sequence, 2, 5, 8, 11, I'm adding 3 each time. So it's an arithmetic sequence where I add 3 each time. Sometimes the notation is what's the most confusing for students historically, so let's figure that out right now. If I wanted to ask you what the first term of the sequence is, let's just look at this sequence, 2, 5, 8, 11. Instead of saying the first term is 2, I would annotate this as a sub 1. That means first term, a sub 1. A sub 1. And the answer would be 2, because the first term is 2. A sub 2 is asking what is the second term of the sequence? 1, 2. The second term is 5. A sub 3, what's the third term of the sequence? 1, 2, 3. 8 is the third term of the sequence. A sub 0, what's the 0th term of the sequence? Well, we only see the first, second, third, and fourth terms. So to find the 0 term, I have to go backwards. In this particular sequence, I'm adding 3 every time, so to go backwards, I'll just subtract 3 to find the 0 term. So 2 minus 3 is negative 1. That's the 0 term, a sub 0. I could find a sub 107 by adding 3 over and over and over and over and over again until I got to the 107th term, but there is an equation that I can get to any high number term in that sequence instead of just adding 3 over and over again. And we're going to learn that equation in our next notes video. Geometric sequences. Instead of being an adding or subtracting pattern, a geometric sequence, you can probably guess by looking at these two examples, is a multiplication pattern. So let's just focus on the second example. I have to figure out what I'm multiplying by to get from the first term to the second term. Now, a lot of us may be thinking divide by 2, but I have to think of what I'm multiplying by each time. And when I'm multiplying by 40 times 1/2 gets me to 20. 20 times 1/2 gets me to 10. 10 times 1/2 gets me to 5. So there will be a lot of fractions, especially with geometric sequences this unit. And then the same notation applies. So a sub 1 is the first term, that's 40. The second term of this sequence was 20. The third term was 10. If I want to figure out the 200th term, I would need an equation unless I wanted to multiply by 1/2 over and over and over again. But because this is a different pattern with a geometric sequence, multiplication pattern, I'm going to use a different equation than I would with an arithmetic sequence. And then lastly, a sub n is asking for any term, any nth term. So this is how our equation is going to start in our next video, a sub n, if I wanted to find any term that I wanted. So we're not using x anymore, we're using n values for sequences. And that's part 1, difference between arithmetic sequence and geometric sequence with some notation. Part 2, determine the common difference or ratio. So I'm going to encourage you to freeze the screen, write these problems down, try them, and then play and see if you have found the common difference or ratio. One hint though before you go, remember differences, a common difference is with an arithmetic sequence or an adding pattern, and a ratio is with a geometric sequence, a multiplying pattern. So here's the answers. For the first one, this one is an adding pattern, and so it's arithmetic, and the common difference is -6 each time. 3 minus 6 is -3. -3 minus 6 is -9. -9 minus 6 is -15. If you didn't know how to find that, you couldn't just look at this and know that you're subtracting 6 right away. Here's a trick. To figure out the pattern, you can take the second term and subtract the first term. So do the opposite of adding, subtract the first term. -3 minus 3 is -6. And then I test to see if that is the pattern. And it is. So the trick again was to take the second term minus the first term, and then check and see if that was your pattern. For letter B, just by looking at this 4, 2, 1, I'm noticing that it's geometric. So the common ratio is I'm multiplying by 1/2 every time. If you didn't know that I'm multiplying by 1/2 every time, go back to the trick. Take the second term, subtract the first term. 2 minus 4 is -2. And then let's check. If I subtract 2 over and over again, 4 minus 2 is 2. 2 minus 2, uh-oh, that's not 1. So this is not arithmetic. Then I'd take the second term and divide by the first term to figure out my ratio. And check that. 2 divided by 4 is 2/4, which simplifies to 1/2. And I'll check and see if that's my multiplying pattern. Times 1/2 times 1/2. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. And it is. So you can use this trick to check. For letter C, I'm not going to use the first two terms because I have a fraction and a whole number. I'm going to use the last two terms, 9 and 3. I'm going to check my trick. So 9 minus 3 is 6. Am I adding 6 every time? No, that doesn't make sense. 1 plus 6 is not 3. So let's divide. 9 divided by 3 is 3. Am I multiplying by 3 every time? 1/3 times 3 is 1. Times 3, 1 times 3 is 3. Great. 3 times 3 is 9. Woo! So geometric ratio is 3. And then for letter D, I'm going to use the first two terms. They're both fractions and they both have the common denominators. So I can easily add, subtract, or multiply these by a number because I have common denominators. So I'm going to start by subtracting. Second term, 4/7 minus 1/7 is 3/7 left. 4 minus 1 is 3. And let's check and see if that's my pattern. 1/7 plus 3 more 7ths is 4/7. 4/7 plus 3 more 7ths is 7/7, which is 1. 7/7 plus 3 more 7ths, 7, 8, 9, 10/7. 10 sevenths plus 3 more sevenths is 13 sevenths. Yay! It's arithmetic because of the adding pattern. D equals 3 sevenths. And that's part 2. Part 3, find the missing term of the sequence. So again, write these down, pause the video, see if you can find the missing terms. Let's get that last one on there. There we go. And then play the video and see how you did. My hint for this one again, figure out if it's arithmetic or geometric. Then figure out the common difference or common ratio. And then figure out what's missing. So here we go. For the first one, I can figure out the pattern by looking at the middle two terms. I see add 5. And I can't multiply by anything that's a whole number. I'd have to multiply by some fraction. That's why I went straight to adding. So if I add 5 to 4, I get 9. Add 5, I get 14. Let's double check the first one. -1 plus 5 is 4. So this is arithmetic. And I'll add 5 one more time to get the fifth term. 1, 2, 3, 4. Fifth term is 19. And then just a review from part 1, can annotate 19 as a sub 5 because it's the fifth term. Letter B, I'm noticing a change from positive to negative, so I'm thinking this is probably going to be geometric because the negative then switches back to positive again. I'm going to be multiplying by some common ratio. And to get from 4 to -12, I know I multiply by -3. And let me just check that common ratio. -12 times -3 is positive 36. So then to go backwards, I'm going to do the opposite of multiplying by -3. I'll divide by -3. 4 divided by -3 is a fraction. It cannot be simplified, so that's my answer. Letter C, I notice the denominators are all 5. So I'm assuming the last term will have 5 as a denominator as well. So I'm going to focus in on the numerators, 9, 18, 36. I'm noticing that I am multiplying by 2 each time, doubling the numerator. So then the last term will be 72 over 5. And that's the fourth term of this sequence. So that would be a sub 4. Letter D, I also noticed that the denominators are all 4. So my missing term will also most likely have a denominator of 4. I'm going to focus in on the numerators. 9, 13, 17. I'm noticing I'm adding 4 each time. Add 4, add 4. So I'm going to subtract 4 to get the missing term. 9 minus 4 is 5. And let's double check. 5 minus 4 is 1. So there's my missing term. That's the second term of this sequence, so that would be a sub 2. Now I have a missing term where I can't figure out the pattern because I don't have extra terms after or before. But I know it's arithmetic. Because I know it's arithmetic, then I also know that I'm going to be adding some common difference twice to get from the first all the way to the third term. So I'm going to set up an equation. 5 plus d plus another d equals 67. And then solve. Subtract 5 on both sides. Divide by 2 on both sides. I know my common difference is 31. So 5 plus that common difference of 31, 36 is my missing term. For letter F, I know it's geometric, so I'm multiplying by a common ratio twice. We get 3r squared equals 48. R squared because it's r times r. Divide by 3 on both sides. R equals square root plus or minus 4, positive or negative. So there's 2 answers here. 3 times positive or negative 4 is negative or positive 12. Let me know if you have any questions. Feel free to send me a an email.